Yeah. Nice. Uh-uh. Mhm. Right. So today we're talking about what it says on the TV there. So powers of I. Um, the goal for the day is to get you to a point where you can work through these in a very algorithmic, repetitive, robotic fashion. Just so the first couple minutes are a little bit awkward, to say the least. Like it's hard to, once you see the pattern, it's easy, but prior to that, it can be a little bit daunting. So the goal is to there's going to be a pattern that emerges as we work through the first 5 minutes here. And the goal is for you to kind of see that on your own, and then we'll discover a quicker way. The end game is this. Like, I want you guys, by the time the lesson's over, to be able to tell me what is I if you raise it to like the 34,519th power. No, it's not. It's not what you think. And that's the plan. So again, end game is the purple thing that we're headed there, and it's super not hard once you know how to get there. So what we're going to do is we're going to discover by just working our way upwards. We're obviously not going to go up to the 34,519th power. That would take like probably a long time. So what we're going to do instead is we're going to do the first like maybe 9 or 10 or 11 until we can see a pattern emerging in math. Like, you guys that did the state math contest saw that, and sometimes in math you're asked to answer a question that not cannot, but really you would not want to try to go to directly. So what you do instead, so what you do is you look for patterns in the little portions that you can do quickly. I know that Sutter and some others were working on, I remember one day when we were practicing for the contest that we found a problem where we were able to do a little bit of a pattern until we realized how it repeats itself, and then we were able to apply that logic to something way in the future. I don't know if you remember that or not. Right. Yeah. Right. Which again, on its own, you can't put into a calculator. You'll get an overflow error. So, anyways, let's get to it. Let's look at how this works. So we're going to start, and we want to be really organized today. We're going to start with just I to the power of 1, and that is, of course, just I. Correct? I know you're like, wow, that's really exciting. I know there's not much there. And then we're going to work our way down to I to the power of 2. And I say down, but I'm actually going to try teaching this lesson. I'm going to switch colors. I'm thinking if I were a student, I would appreciate a color change right about now. What is I to the second? It sure is, right? It's -1. Good job. And now we're going to head over and do kind of one that is a little bit now outside of our comfort zone, and that is I to the third. It is -I. Now, the way this works is, and I won't go through probably this much detail like every time, but bless you, the way I to the third works is, if you think about it, it's a collection of I squared times I to the 1, right? Just your basic properties of exponents tells you that 2 plus 1 is 3. So if you take I to the third and divvy it up, then you can take its little component pieces and make an answer out of it, which Cooper did really, really fast. So what is I squared? -1. And what is I to the 1? So the answer is exactly what Coop said, and that is just -I. Okay. Any questions about that? That can be a little confusing at first. The key to these first ones, to understanding where they come from, again, is to understand how you can break something into manageable pieces. Like, if you already know what I to the second and I to the 1 are, then let them guide you to what I to the third is, right? And then we also would use the same logic when we get to something like I to the fourth, which it would. And it's interesting. I think it's interesting because I to the fourth is just a collection of I squared multiplied by another I squared, right? And we know what each of the I squareds is. They are -1 and -1, which presto equals 1. Got it? Now, at this point in time, I've set up my board this way because I've always taught this lesson vertically, and I thought, boy, I should do this horizontally. I'm going to cycle back across now. I'm going to come back down to the left, and you'll see why here in a second. As I continue my pattern with my powers, there's 1, 2, 3, 4. Logically, what comes next is I to the 5th power. And it's just going to be I. And the reason, again, for that, and I can prove it to you, is because it's I to the 4th times I to the 1, right? And I to the 4th is 1, and I to the 1 is I, and 1 times I is I. And you can probably guess, I think this year I've been pretty blessed with a lot of really pretty observant and smart students. You can probably guess what's happening from here on out, but let's check a couple more to sort of verify that this is legit. So, oops, I forgot to switch colors. Let's go with I to the 6th power. You already know it's going to be -1. And let's take a quick peek at why that is. So we can break him down, try to use the most intelligent chunks that you can. I feel like breaking it into I to the 4th and I to the 2nd is a pretty logical choice. What's I to the 4th? What's I to the 2th? And 1 times -1 is presto. Got it? So we'll do a couple more, and then I won't go through the process of proving it to you anymore, because what you find is I just keep using things that I've already discovered to prove what next things are. Like if I wanted to do I to, bless you, like I to the 21st power, at some point I'm going to use some combination of like I to the 20th, which I would have already figured out, times I to the 1th, which I already know, right? So using things we already have, no big deal. So next up is I to the power of 7. You already know what it equals. Let's take a look at why. And so what would you break I to the 7th down into? Yeah, and honestly, there's no real perfect right answer. Like Corbin said 1 and 6, you said 2 and 5. You could do 4 and 3. It's what an interesting thing. Like you can use literally any of those things that you said because we've already got access to all of them, right? They're all previous knowledge. So I don't think in all my years of teaching this, I've ever done I to the 6th and I to the 1st, but I like it. It's clever and it works really slick because what's I to the 6th? We just figured it out. And what's I to the 1th? And -1 times I is -I. You'd get the same result if you had broken it down instead of 6 and 1 into like 5 and 2, 4 and 3, because you've got everything you need already at your disposal. And then, of course, the last one before we start looking for the shortcut is I to the 8th. And, obviously he's going to be the same as his brother from before. We know it's going to equal 1. And I think it's pretty easy on this one. Logically, I would go I to the 4th and I to the 4th, which is 1 times 1, which is, well, 1. And then you rinse and you repeat. And so if I asked you to fill in another row now at this point, you would just head on over to I to the 9th and you would say, well, I know it equals I. And then you would head over to I to the 10th and you would say, I know it has to equal -1. I can't believe I didn't think to show it like this years ago. It's just, there's no way that doesn't make sense. And then I to the 11th is -I. And then I to the 12th is, of course, 1. And so that begs the question, going back to 5 minutes ago, when I put that thing on the board originally and I asked you, like, or told you this is where we're headed, let's start thinking now about how to make predictions. And what it's going to come down to is it's some form of like modular arithmetic. We're going to study remainders, kind of like we used to when we were kids. The pattern has a length of 4, right? You can clearly see that there are 4 items in the pattern. And so whenever you see a pattern like this, you want to divide by that number. If there were 3 items, if it went like something, 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 repeat, something, 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 then we would be talking today about dividing by 3, but we're talking about division by 4. So let's study remainders when we divide by 4. This is the part that could get confusing, so just be careful, right? Just stay with me. It's not confusing if you're on guard. So we're going to take and we're going to divide by 4. And I'm just going to study one row, for example. So I'll just take this row. Why not? So we're going to take the exponents one at a time. And we're going to study like how to discover how this works. We're going to take the number 5. We're going to divide it old school by 4. Your calculator will also help. We'll start to see things once you understand what's going on. Then the calculator is going to give us different looking remainders, decimal remainders, and we'll understand why they are what they are. So how many times does 4 go in 5? 1. And I'm not interested in that, but I am interested in the fact that 1 times 4 is 4, and then that the subsequent remainder is 1. So I feel at this point like what I can do is I can assign a value, watch out now, I can assign a value to this column right here and say that if you're in this column, when you divide by 4, your remainder is 1. Check it if you want to. Like the next number down below the one I just did from 5 was 9, right? 5 to the 9th. What's 9 divided by 4? With a remainder of. That would keep happening. The next one below him would be I to the 13th, and then I to the 17th. And all of those numbers, when you divide them by 4, have remainders of 1. So I can start to think into the future now that if I divide any number by 4 and I get a remainder of 1, I'm sure that the answer is going to be I, because it has to go in that column, right? Now let's study the next column. And again, let's just pick a number like this one. Oh, I just circled it in red there. I know it's kind of hard to see. 6. If I take 6 and I go old school, grade school division, divide by 4. 4 goes into 6 one time. 1 times 4 is 4. 6 minus 4 is a remainder of 2. And that would be the same for any number in that column, right? Think about all the powers that you can see. You can see 2 and you can see 6 and you can see 10. But after that would come 14 and 18. And all of those numbers, when you divide them by 4, give you a remainder of 2. So at this point in our notes, we can assign to this column a value of r equals 2. And this is about the point where as a student, I might check out and say, duh, like, shut up, Mr. Aaron, I get it. The next ones are r equals 3 and r equals 4, right? They're not. So let's go to the green column, and I'll make this a little quicker. If you take 7 and divide it by 4, what's the remainder? It is 3. So we can assign a value to this column and say the remainder is 3. But be careful and understand just basic number theory here. If I take any of the purple exponents and I divide them by 4, what's my remainder? Correct. And that's just a number. If you take classes in college where you really study number theory, you'll figure out that, you can't have a remainder of 4 if you divide by 4, right? If you divide by n, the biggest remainder you can have is n minus 1. So I can then assign a value to this column of saying the remainder is 0. And I'm here to tell you, there are literally only 4 things that can happen when you divide by 4, provided that you're working with integers. You can get a remainder of 1, 2, 3, or no remainder. So having said that, if every number falls into either the white, red, green, or purple category, I then look at something and I say, I can do this now. If I said to you, what do you guys do and write down the one I said earlier? Let's just make one up. Let's say it was like 34,519. That might have been it. I don't know, something like that. That was seriously it? Dope. So let's go and do some old school division. Sorry, we're about to bust out some 4th grade math here, but let's make this happen. So we're going to do 34,519, and we're going to old school divide by 4. And I'm guessing, and Cooper, you're exactly right. I just don't want to go that fast. Okay, I hope you understand, right? You understand. I know. I know. Yeah. Yeah. I always wonder, do I want to take the Cooper-Allen pathway? But then I feel like I'm going to cause trouble. So I'm going to go nice, slow, and steady. So how many times does 4 go into 34? 8 times. 4 times 8 is 32. 34 minus 32 is 2. Drop the 5. You did this years ago. How many times 4 go into 25? 4 times 6, 24. Subtract, you get a 1. Drop the 1. How many times 4 go into 11? 2 times. 2 times 4 is 8. 11 minus 8 is 3. Drop the 9. Sorry for that, 3. And then 4 goes into 39. 9 times. 4 times 9 is 36 with a remainder of 3. Right, I know it's been a minute. It's been like a lot of minutes. So if the remainder is 3, that tells us that we are definitively in the green column. What is the answer then to I to this big obnoxious power? It is negative I. Good. Because I don't want to put you through this, and listen, what Cooper is saying, if you're interested, it's some good number theory. Divisibility by 4 is a magical thing. Like he said, if you want to hear this, the last 2 digits are all that matters with 4s. I hesitate to teach this because I don't want someone to come back and use this as a test for like 3s or 8s or something like that. Like it works for 4. Clear? 4. But if you look at the last 2 numbers, quite frankly, yes, they are all that matter because 4s and 100s play nice together. So anyhow, let's look at a quicker way to do it. Let's watch what happens if we type this into our calculator. So that, I mean, you can approach this however you'd like. I don't really care, as long as you're not like photo mathing it. Let's take 34,519 and type it into your calculator divided by 4. And I'm not interested in all the stuff that comes before the decimal. What I'm interested in is the decimal, and it's what? Correct. So that tells me that the remainder is 0.75. Now, that's not technically correct. The remainder is not 0.75, but it comes into that like feel. And you would agree that 0.75 is 3 out of 4. So there's where you can draw the conclusion that the remainder is 3. Does that make sense?
Yeah.
Okay, let's practice. Let's do another one. I'll write it in like green over here. Let's do I to the power of 4,121. Again, I'm not interested in all the crap that the 1,000, whatever that comes before. I'm interested in the point, blah, blah. What did you get? 0.25. And 0.25 is 1 out of 4, right? That tells me then that my remainder would have been 1, which places me squarely in the white column. So what is the answer to that green problem? It is I. It is I. That's 120. Got it? So I want you to look at the remainders and then another kind of remainder that you might be interested. Let's say we had to do like I to the 5,262nd power. Type that one in, divide it by 4, and let your eyeballs fall on what that remainder looks like. Do you see the 0.5 there? So if you want to go the calculator road, just study your remainders. If you get a 0.25, then you equate that to the white column. The remainder is 1. Okay. If you get a 0.5, you equate that to the column where R equals 2. If you get a 0.75, you equate that to the remainder being 3. And if you get a whole number with no decimal, then you of course know that the remainder is 0, and then the answer is 1. You got it? That was a pretty short lesson, right? So today you'll be working on whatever you were working on yesterday, in addition to, there's a new Delta math that assigned itself about 12 minutes ago, and that's just powers of I. So just this should go lightning quick. If you understood that, then this should go like really. Okay. Those are your jobs for the day. That is what you are going to do. Boom. I almost stopped the recording and I didn't. Yes, thank you. I forgot about this. My bad. Bryce had like something like I to the 17th times I to the 4th times I to the, we'll just make it up, 9th, right? Oh, I'm so sorry. I forgot. The rules of exponents tell us that we can add these exponents together. You know that, right? So like I would just take 17 plus 4. What's that? What's 21 plus 9? So Bryce's problem is really just I to the 30. And what's the remainder when you divide 30 by 4?
0.5.
Yeah. So, got it?